Now we are gonna solve some of the questions of review exercise 3 from D2 7th edition. It's question number 1. For example, we can have its part B, which is negative 3b times 7 minus 4b. So we can multiply this with this and this with this. So that would give us negative 21b, and then this negative and this negative would be positive, and 3 fours are 12b squared. Then we can arrange them in descending order, though it is not necessary, but we can do it. 12b squared minus 21b. So that can be the answer. Okay. In the same way, we can do its remaining parts. For question number 2 now, expand and simplify each of the following expressions. Let me have part B and D for this. For part D, that would be 6h squared plus. Now I am splitting this multiplication so that you can understand that first of all, 6h square is being retained the same, no change in that. So I'm just going to multiply this with this first. So 2h times h, that would give me 2h square, and then 2h times negative 1, that is going to be negative 2h. And then now I'm going to multiply 3 with h and 3 with negative 1. So 3 times h is positive 3h, and positive 3 times negative 1 is negative 3. So now we open the bracket. You see there is a positive sign before this bracket. So the terms inside the bracket are not going to have a change of sign. So the signs would be the same. So 6h square plus 2h square, that is 8h square. Now solving them together, negative 2h plus 3h is plus h, and then negative 3. So since all of these terms are different, h square term, h, and a constant number, so we cannot add or subtract them. So this is going to be the final answer. Okay, now for part D. M is to be multiplied with this m to make it m square. Then this m is going to be multiplied with 1. So m times 1 is m. Then 2 times m, that is 2m. And then 2 times plus 1, that is plus 2. Then there is a negative sign, so I need to be cautious. So I'm putting this bracket. Now this 3m is to be multiplied with 9. 3 nines are 27m. Then this 3m is going to be multiplied with negative 5m. So that will give me negative 50m squared. And then 5 times 9, 45. And then 5 times negative 5m, that is negative 25m. Now m square, we can simplify them to have 3m plus 2 minus, I'm writing this negative 15m square first, and then 27m minus 25m. That would be positive 2m and then plus 45. Now we can open this bracket. When I'm opening the bracket, you need to be cautious that this negative got multiplied with this negative to have positive 15m square, negative times positive negative 2m, and then negative times this positive sign, this is again negative 45. Now the like terms are these two. Combining them, we get 16m square, and then 3m minus 2m, that is positive 1m, and then finally 2 and negative 45. That will give us negative 43. So this is how we need to solve this question. I hope it would be clear to you. Okay. Now we can see some of the parts from question number 3. Factorize each of the following expressions completely. As we can see that each of square terms in all of these parts, their coefficient is 1. So it is going to be a simple method to simplify them or to factorize them. Let me choose part D to solve it. D square minus 12D minus 45. If you just compare it with the general form of quadratic expression, so we can deduce that the value of A is 1, B is negative 12, and C is negative 45. This is actually that the coefficient of square term is 1. So the value of A is 1. The coefficient of X term is negative 12 and the constant term is negative. So this is how we do it. Okay, then we need to see A times C, that is 1 times negative 45, which is negative 45. And now we need to have the prime factorization of 45 to have negative 8, negative 12, sorry, when you add or subtract the factors. So this is it. 5 3s are 15 and then 3. So we can simplify them like D square would be the same, negative 45 would be the same, and negative 12. We can achieve this negative 12. Multiplication of A and C is beta a procedure that, like for example, you need to have the coefficients of square terms multiplied with the constant term, and whatever you will get as a result, A times C, you will make the factors of those. We have made the factors of this 45, and now from these factors we need to have a pair of factors such that you add or subtract them, you get the middle term, and when you multiply them, you should again get this product A times C. So, and then we discussed in the previous exercise that out of these two factors, the larger of the factors has got to have the same sign as the middle term. In this case, you see that middle term is negative 12D. That means it is having a negative sign. So the larger of these two factors, which 15 and 3, larger is 15. So larger factor is going to have a negative sign with it, negative 15. And 3 is going to have plus sign so that we can have negative 12. So let me write down 3D first and then negative 15D. Now if you see, you add them, positive 3D and minus 15D, you will get negative 12d, and when you multiply them, 3 times negative 15, you get negative 45, same as this one that you had already 8 times. So continuing now, we need to have the pair of this one. D is common from this pair. So D plus 3 is remaining from these two terms. And if I combine these two terms, negative 15 can be taken common from these two. From the first term, I'm left with only D. And since I've taken negative sign common outside, so this negative sign would become positive, and 15 threes are 45. So now you see that D plus 3 is a common factor to these two. So we can retain it as a common factor, D plus 3 taken common. From this term now, I'm left with D, and from this term, I'm left with negative 15. So D from this one and negative 15. So now you see these three terms, which were originally written as a sum or difference, now we have got them written in the form of a product. So that means our factorization has been done. So that is the final answer. Okay, in the same way, we would be solving question number 4. If you see question number 4, see, compare the coefficients 9, 18, and 16. Can we have a single factor taken as a common from these two? No. Similarly, 3, 19, and 14. We cannot take a single factor common from these three. But if you see part C, 14, 49, and 21, you can take 7 common. Similarly, if you consider 18, 39, and 18, you can have 3 as a common factor. So actually in this question, we are having two different types of questions. One are these in which you cannot take something common. And these are the two parts in which you can have some common factor like this. Okay. So I will be discussing each type separately. Let me solve first of all. Let's suppose part B. 3h square minus 19h minus 14. Since as we already observed and discussed that we cannot take something common from these three. So we are going to apply the same procedure. First of all, I'm going to have it compared with this so that I can have the values of A to be 3, B is negative 9, and C is negative 14. Okay, once we are done with this thing, now I need to have this A and this C. So 3 times negative 14. Negative 42. Now we would be having the prime factorization of this 42 so that when you add or subtract these factors, you get negative 19. Okay, let's do it. 2 21s are, 3 7s are. and 7. So obviously 7 is a 21 minus 2 would give us 19. But since we discussed this thing that the larger of these two factors has got the sign which the middle term has got. Since the middle term has got negative sign, so I'm bound to write down negative 21. With this, I need to have a balance negative 12, 21 plus 2 so that I can get negative 19. So this is what we need to do now. The first term as it is, the last term as it is. For this negative 19, I'm going to have negative 19, negative 21 h and then plus 2h. Now, let me group them together, the first two and the last two. We can see that 3h is common from these two. So I'm left with just 1h from this minus, since 3 sevens are is 21. So 3 already taken common, h already taken common. So I'm left with just 7, h minus 7. Same goes for the next pair. I can have, since this is a positive sign, I put a positive sign here. Then 2 can be taken common from these two. So h minus, since this 14 is actually 2 times 7. So we have already taken this 2 common and we are left with this 7, h minus 7. So now you can see that h minus 7 is common to these two. So we can have h minus 7 taken common. Since this has been taken common, we are left with 3h from the first term and then plus 2 from the second term. So we have written them as a product. That means our factorization is done. So that is your answer. Okay, that was part B. Now, part C and D are alike. Let me solve part D and I would be giving you a starter for part C as well. For part D now, 18m square minus 39m plus 18. If you again compare it with ax square plus bx plus c, you will come to observe that the value of a is 18, b is negative 39, and c is 18 again. So you need to have a times c, that is 18 times 18. That means you need to have the factors of 18 times 18, which is 324. We need to have the prime factorization of 324. 2 1s are 2, 2 6 are 12, 2 7s are. And then since we discussed this thing that now you see we cannot have this taken as directly to have this negative 39. So what we need to do, we need to reconsider it. We need to rethink it. As we discussed at the beginning, that these are the parts in which we can take something common. You see, if you do not take common and keep start doing it, you will be stuck like this and you won't be able to get any factor to have this middle term. So what you need to do at the first, you need to do it taking something common from these three. 6 is common? No, 3 is common rather. So you can take 3 common from all these 3 terms. So 3 6 are 18, 3 1s are 3, 3 3s are 9, 13, and then 6. Now you can apply this method to this expression inside the brackets. So the value of A now is 6, the value of B is -13, and the value of C is 6. So now A times C, that is 6 times 6, that is 36. So you now need to have the prime factorization of 36. 2 18s are, 2 9s are, 3 3s are, and 3 1s are. You need to have -13. So what we need to do is 3 3s are 9 and 2 2s are 4. 9 and 4 will give us 13. So let's do it. 3 taken common already. Now 6m square would be the same. The last term 6 would be the same. And then this -13m can be written as -9m, -4m. So -9m minus 4m will give us -13m. And when you will multiply them, -9 times -4, you will get this 36. So proceeding it like this. Now pairing up the first two terms, you can have 3m common, then 2m minus 3. Then from these two, you can have just 2 common and you are left with 2m. And since you have taken this negative sign common here, this positive sign would change to negative and then 3. So 2m minus 3 is a common factor once again. So this is the same 3. Within this bracket, you are having 2m minus 3, then 3m minus 2. So our factorization is complete. This is how you do the factorization. So as I told you that we would be discussing the starter of this part C as well. So since again we can see that the coefficients are having a common factor of 7. So you can take 7 common. So you would be left with 2k squared plus 7k plus 3. So now this question would be starting from this point and now you need to carry on as it is. So this is how this question number 4 had to be done. Now I proceed to question number 5. Factorize the expression this completely. Okay. Now you can see that the middle term is having a fraction in it. So to avoid a fractional working and to make these numbers as whole numbers, what we can do is that we can take out 1 by 2 as a common factor and make all numbers as whole numbers. So let's see how we can do it. Okay, you see that 2 is in the denominator. It is having 1 in the denominator. This is also having 1 in the denominator. So to make the denominator same, let me multiply the rest of the two terms by 2, and to rationalize them or to equalize them, we need to multiply the numerators as well. So multiplying the numerator as well as the denominator by 2 of these two terms, so that we are having now 6x squared by 2 minus 11 by 2x minus 10 by 2. Now you see that 2 is occurring as a common factor in the denominator of all these terms. So we can take 2 common. We are left with now 6x squared minus 11x minus 10. Now this is a question of this type we cannot have a common factor from these three. So we would directly be applying that method of A times C, 6 times negative 10, negative 60. Now the factors of 60 are 30, 15, 5, and 3. We need to have 11. 5 threes are 15 and 2 twos are 4. So the factors are 15 and 4. So it is going to be like this. The last and the first terms are the same. And for this negative 11, I can write it down plus 4x negative 15x. So that when you add them, you will get negative 11. And when you just multiply them, you will get negative 60. Okay, then 1 by 2, the pairing of the first two terms, which is 2x taken common, and then you are left with 3x plus 2. And from these two terms, 3 can be taken common, and you are left with, 5 can be taken common. So 3x, and since we have taken this negative sign common, so this negative sign would change to plus sign, and then this. So 3x plus 2 is now again common. So in this way, you have completed the factorization of this. So that completes our review exercise 3.